Hey class, I hope everyone's happy, healthy, and safe out there. I know these are strange times that we're living in. Um, I wanted to show you something that's going to be on the test, and I wanted to put it in very plain terms, and here we go. So, this is in your workbook, right? And so it says, assume a table critical value of 0.49 for the problems described below. In each case, indicate the appropriate conclusion of the observed correlation values. So this sounds hard and scary and bad, right? But it's actually not that bad. So they give you that critical value of 0.49, and then they give you an observed value. What I would do to understand this is I would draw the x-axis and the y-axis, and then draw a parabola, just a line like this. All right. They just gave you the critical value, or we could call it the p-value, as you'll learn in your online materials, PowerPoints, 0.49. So I put positive 0.49 on this side, and then I go, right? And then I do a negative 0.49 on that side, because that is the critical value, okay? Then the problem says they gave an observed value of positive 0.50. Now on the test, we want to know, number one, is it positive? Well, it's got a big fat positive, so yes, it's positive. Is there a strong correlation between these variables? In this case, it is strong because it is past the critical value number. Is it significant? Yes, because 0.50 is past 0.49 in this kind of darkened area that you did, meaning it is statistically significant. All right, let's try it again. The problem gives you a critical value of 0.49. All right, you have it on this side and you have it on this side. They give you an observed value of negative 83. It's a big number. Number one, is it positive or negative? Obviously, it's negative. It's got a negative right there. Is it strong, moderate, or weak? It's actually quite strong because it's way in the, it's off the map, right? It's off the graph. It's way in the statistically significant darkened area of the parabola. Okay, and is it significant? Yes, it is statistically significant because it is well within and beyond 0.49, meaning it is in the statistically significant tail of this two-tailed parabola, right? Okay, let's do it again. It asks observed value of negative 0.88, right? Observed value negative 0.88. Is it negative? Well, of course. There's a negative, so I wrote down negative here. Number two, is it strong, moderate, or weak? It's quite strong because it's past 0.49 and it's in the darkened area with of this tail of this parabola. And is it statistically significant, or is it due to chance? It's statistically significant because it's in the darkened area of the tail of the parabola. Okay, and let's do the last one. They give you an observed value of positive 0.04. Number one, 0.04. Is it positive or negative? It's positive, right? Because it gives you a positive right there. Is it weak? Is the relationship between these variables weak, moderate, or strong? It's actually weak because it falls within this bell part of the bell-shaped curve, right? It falls within here, so the correlation is, and the relationship is weak. We're not too concerned about whether you know things are moderate. I mean, moderate, you kind of eyeball it. It's between this weak part and this black and strong part. So I guess if something was, I don't know, 0.40 right here, I would say that it's a moderate strength of the relationship. But you probably won't have to worry about that too much. And then, is it statistically significant or due to chance? I wrote due to chance. Why? Because if I were to plot this on this graph, that's about right. Isn't that where 0.04 would be? Well, is that in the blackened spot? No. It's well within the bell, right? The bell shape of the bell shape curve, aka a parabola. And so this is not statistically significant. It is due to chance. Again, because it is not in the darkened black area of the tail, which would indicate that is statistically significant beyond that point. But 0.04 is right there in this white part, which is due to chance. Okay. Hey class, I just wanted to drill down and clarify one section, namely the weak, moderate, strong correlation second column notion. I think it really help folks to use this kind of table here of 0.00 to 0.39 is weak, and then 0.40 to 0.59 is moderate, and 0.6 to 1 is strong. I'd like you to use that going forward. So if we use this little table, we look at 0.50 would fall in the moderate range, so we put moderate, and for this number would fall well beyond strong, so we put strong. Same thing here, falls in the strong range, and the same, well, the 0.04 would be weak because 0.04 falls between here. So I just wanted to clarify that, just so no one is confused about that section of weak, moderate, and strong correlation between several variables. Okay, thanks so much. Have a good one.